Look at solving simultaneous equations with three unknowns, x, y, and z. There are different ways to do this, but I'll show you my preferred methods. Example 1. Now, if you have a set of simultaneous equations where it's easy to rearrange one of them for x, y, or z, then I'd recommend you do that first. In this set, it'll be pretty easy to rearrange either the first or second equation for x. I'm going to do that for the first one to make it x equals 5 plus y minus 3z. Now I'm going to take that x and sub it into the other two equations. Get 5 plus y minus 3z plus y plus 6z equals 12. Tidy that up and you get 2y plus 3z equals 7. And then subbing into the other one gives this. Expanding and simplifying, tidy up and you get y minus 7z equals negative 5. Now we have two equations with just y and z in them. Two equations with two unknowns means we can solve for those simultaneously as we normally do. So you can line them up on top of each other and then do your preferred method for simultaneous equations here. For this one, I would probably times the second one by 2 to make it 2y minus 14z equals negative 10. And then stick the other one on top again and then subtract the two equations from each other. Because the y's match, they'll be eliminated. And you get 17z equals 17, therefore z equals 1, and that's one of our final answers. I can then sub into 2y plus 3z equals 7, replace the z with 1, and solve for y. Now we know that, we can sub y and z into the original x equation. X equals 5 plus y minus 3z means x will be 5 plus 2 minus 3. X equals 4 in this case. Example 2, what to do if all of the x's, y's, and z's have numbers in front of them. If this is the case, we need to choose a variable to eliminate first. Now in this case, I'm actually going to choose the z because I can see we've got a 5z, a 15z, and a 10z. Those are all multiples of 5. So if I start by multiplying the first equation by 2, I'll get 4x plus 6y plus 10z equals 42. And then place the third equation underneath that, so 5x plus 4y plus 10z equals 37. And then because the 10z's match, we can eliminate them by subtracting. So we get minus x plus 2y equals 5. So those two equations came from timesing the top one by 2 and then just taking the bottom one as it came. Next, we can times the top equation by 3 to get 6x plus 9y plus 15z equals 63. Then copy down the second equation underneath it, so 3x plus 6y plus 15z equals 51. Again, now the z's match, so we can eliminate them by subtracting. 3x plus 3y equals 12. So once again, that came from timesing the top equation by 3 and then taking the middle equation as it came. Now we have two equations in two unknowns, x and y, which we can solve simultaneously. If we times this equation by 3, we'll get minus 3x plus 6y equals 15. And then the other equation underneath is 3x plus 3y equals 12. I can add those two together to eliminate x and get 9y equals 27. Therefore, y is 3. Sub into any of those equations to get x. Let's go for minus 3x plus 6y equals 15. So minus 3x plus 18 equals 15. Minus 3x equals minus 3, so x is 1. Once you know x and y, you just need to find z. You can do that by subbing into any of the equations. I'm just going to choose the top one. 2x plus 3y plus 5z equals 21. Sub in the x and y values we just found, and we get 2 plus 9 plus 5z equals 21. Therefore, 5z is 10 and z is 2. That's it for now. If you found this video useful, please do remember to like, comment, and subscribe to my channel if you haven't already. And do share this with anyone else you think might find it helpful. Thanks, and see you next time.